For the next few moments, I will be giving you a demonstration of the Nastran Solution 200 web app. Just in case you're new to this web app, this tool lets you take an existing Solution 100 PDF file and it allows you to convert it to Solution 200. You can create your variables, your objective and constraints, and I'll go into more detail regarding the process in a few moments. Now, this is the example we will be working today. This is the 3-bar truss. It's a very basic example. For this demonstration, I'm going to perform a more complex demonstration. We are going to perform a multidiscipline optimization where we optimize for 2 different analysis types. On this slide is just a quick overview of the optimization problem statement. We are going to vary the cross-sectional areas of the truss members. We are going to try and minimize the weight as much as possible while satisfying both stress and displacement constraints. Since we are performing a multidiscipline optimization, we have this second analysis type constraint. Here we want to make sure that the first natural frequency is above 80 Hertz. So this is our goal. We want to take this truss that has an initial weight of 4.82. And by the end of the video, after optimization, we will reduce the weight to 2.7 pounds. Now let's go ahead and start the process to convert this PDF file. This PDF file was already created in your pre-post processor. Let's go ahead and navigate to the web app now. You can see on the screen that there are 3 options if you want to perform topology or topometry optimization that's supported in the web app. We are interested in performing a size optimization, so we will load this web app. Let's go ahead and select this PDF file. When you upload the PDF file to the web app, it identifies all the properties that can be set as design variables. Let's go ahead and select the 3 areas as design variables. Here, other options include the Young's modulus, the Poisson ratio, the density, and the list is quite long. The first thing to pay attention to is the right-hand side of the screen. The web app will actively generate your Solution 200 bulk data entries. You don't see it at the moment, but it's also maintaining the case control section. It's including all the necessary statements. Here are the 3 newly created design variables, x1, x2, and x3, that correspond to the 3 areas. Let's go ahead and focus on the objective now. There's a long list of response types I can set as the objective: weight, volume, displacement, and so on and so on. Here, I want to select weight as the objective, so we'll click on the plus icon. And here I want to minimize the objective, and that completes creation of the objective. Let's focus on creating our constraints. I want to create a stress constraint, and I want to create a displacement constraint. Here in the next table, you notice that the status column is marked red. If you ever see a column that says where the status is red, that indicates that that entry will cause a user fatal message when Nastran is executed. So you want to make sure that you always avoid these red status symbols. Let's go ahead and configure the stress. We want to constrain the stress for any element associated to PROT 11, 12, and 13. We specifically want to constrain the axial stress, and the lower bound is 15,000 units of stress and positive 20,000 for the upper bound. For displacement, we want to constrain the x and y components, and for the lower and the upper bound will be negative 0.2 and positive 0.2. I'm going to purposely leave this field or this cell empty. You notice that it's saying the input is required. The status column is red. I want to show you later on what happens if I accidentally forget to complete all of the entries. So this completes the creation of the 2 stress constraint or 2 static constraints. Let's go ahead and switch over to normal modes, and we'll go ahead and click the plus icon for frequency. Here we have our new constraint for frequency. We want to specifically say that this is for the first natural frequency. The lower bound will be 80 Hertz. And now we are done with the constraints, let's go ahead and move on to the subcases. We are performing a multidiscipline optimization, so we have to make sure that the subcases are properly labeled. Prior to this demonstration, the bulk data file has already been consolidated. All the entries for normal modes analysis have been merged into the static analysis bulk data file. Here, we'll go ahead and change the analysis type to modes. This gives me the ability to mark this checkbox for R3, which is the natural frequency constraint. Let's go ahead and mark the checkbox. You can individually mark these checkboxes, or you can hover over the checkboxes and highlight them that way. Alternatively, you can simply select this one green button. This will go ahead and mark all the visible checkboxes. And so we've applied all the constraints to all the subcases, and more importantly, we properly configured this to perform a multidiscipline optimization. Let's go ahead and move on to the exporter. This is where you can export your newly converted bulk data files. One thing to keep in mind is that the solution number is solution 200. Before, the PDF file that we uploaded was labeled solution 101. So this is just to prove to you that the conversion has happened. You'll notice that for subcase 1 and 2, new case control commands have been added. For example, here's one for the objective, one for the analysis type, one for the constraint group, and so on and so on. Here you have two options to download your bulk data files. But before that, you'll notice there is a big red error message at the bottom of the screen. Remember that constraint that was not completed. This error message is telling me to jump to this table and correct the error. So once I complete that, here we want to constrain node 4, and I go back to the exporter, the error message disappears. So now I can go ahead and download this package. This package includes the bulk data files and a special program that will automatically start Nastran for you. It does other things too. It opens a status page. So if this is a lengthy optimization, you can track the progress of your optimization. If the optimization is complete and successful, it will open a second page. This second page will automatically load the results for the optimization. Keep in mind, the web app is not installed on this machine. The web app is installed on a separate machine with this IP address. All I need is Google Chrome to access the web app. Here are the final results for this optimization. You can see we started off with a weight of 4.82, and as promised, we ended at a weight of 2.7. Here we scroll a little further down, you can see the change in the design variables. I can turn some of these variables on and off and view them very carefully. So that's the first part of this demonstration. Let me go ahead and close everything. Let's now assume that we are leaving for today and we come back into the office tomorrow. Let's say you want to continue your work. What is the procedure for that? Let's go ahead and open Google Chrome again. We will go ahead and navigate to the web app and go back to the web app, rather the size optimization page. If you select the files, you can import the same PDF files that were previously exported. Here, let me upload these files. Those bulk data files that were previously exported can be brought in back to the web app. Here you can see that all the variables have been imported properly. The objective is in here, and so are the constraints. So you can continue your work because of this saving or exporting capability in the web app. Let's move on to perform a more complex optimization type. You can also perform sensitivity analysis, but here I want to demonstrate the use of global optimization. This requires the use of multi-opt Nastran. This could be a little complicated if you're new to this optimization type, but the web app takes care of a lot of the fine details for you. So here I've marked global optimization. If you go back to the exporter, you'll notice that we have a new error message that appears. The variables have to be properly set. If you want to use multi-opt and global optimization, one requirement is that you set both the lower and the upper bounds. The web app has been programmed to catch this. So let's go ahead and correct this right now. And once we're done with that, we can go back to the exporter and download a new package. So let's go ahead and extract these contents and perform our global optimization. So like before, when you automatically start Nastran, it opens a status page. It's going to keep track of every sample, if you will. Here you can see that this is currently on design cycle 8. This sample has completed. This next sample is completed at design cycle 4, and it's going to keep repeating the process until the entire optimization is complete. So just as a reminder, while this is happening, the web app will catch you if there are any errors. This is to prevent any user fatal messages. This is done via the status column. The web app will help you convert an existing 100 BDF file to solution 200. The web app is capable of performing more advanced optimizations such as global optimization or sensitivity analysis. The auto execute program allows you to make use of the web app even more by tracking the progress of the optimization. And then in the end, if everything goes well, you can see the results, and here I have the results of the global optimization that we can inspect at a later time. I think that's everything I wanted to cover. There's one last thing I want to cover, and it is regarding future capabilities. If there's a capability you are interested in seeing in the web app, feel free to send me an email and I'll see what I can do regarding your request. But here's just a quick glimpse of what is to come. Today, if you want to update your original file with the optimized areas as an example, or any other property, today you have to manually open up the PCH file. So let me show you what that looks like. You have to open this file up manually. You have to copy these new properties. You can see that the areas are the optimized ones. You then have to open your original bulk data file and replace them manually. In the next few weeks, there will be a project to make this automated. So again, if you have any suggestions, feel free to email me. The next thing that's on the plan rather is multi-model optimization. Given the web app's support for the case control section, the bulk data entries, the auto execute program for Nastran, the web app is at a point where we can grow and start supporting multi-model optimization. That is the end of the demonstration. As always, if you have any questions, feel free to reach me.